Agent costs are not just the price of a single model call. They build up as the system plans, reasons, uses tools, retries, validates, and produces an outcome. In this module, we'll treat that full workflow as a FinOps discipline. Previously, we connected FinOps principles to the cost behavior that makes Agentic AI different: autonomy, iteration, tools, quality checks, and variable paths. Now we'll move from isolated drivers, like tokens or API calls, to a repeatable way to estimate cost per workflow, task, and business outcome. The challenge is that an agentic app does not have one predictable price per request. A single prompt can trigger retrieval, tool calls, validation, and retries. Average token cost may look healthy, while specific workflow paths quietly become expensive, risky, or difficult to govern. Cost modeling begins by turning an agent workflow into measurable units. Rather than treating a request as one expense, break it into planner calls, reasoning loops, retrieval, tool use, validation, and response generation. Then attach the right cost driver to each unit: tokens, API fees, compute time, storage access, or human review. Include conditional paths as well, such as retries, fallback tools, or extra validation after a failure. This gives you a cost map you can use to attribute spend, forecast volume, and identify the best optimization targets. Planner and reasoning costs are often underestimated because they occur before the visible work. A planner may use a larger model and a wider context window to interpret the request, constraints, and available tools. Each reasoning loop can then add another round of analysis, outputs, and revised inputs. Cost does not grow only with final answer length. It grows with model tier, planner tokens, number of steps, and tokens per step. Optimization means asking whether planning can route to a smaller model, prompts can be compressed, or iteration depth can be capped without reducing quality. Retrieval adds another cost chain before the model answers. A request may create an embedding, query a vector database, read stored documents, and sometimes run a reranker. Those steps carry direct infrastructure or API costs. Then comes the hidden multiplier. Retrieve chunks are added to the prompt, so the LLM processes more input tokens every time. If retrieval is imprecise, you pay for noisy context and may get worse answers. Model this with query volume, chunks returned, average chunk size, reranker use, and added tokens. Token spend is only one part of an agent's cost. Each tool invocation can create a separate charge: search API fees, database queries, serverless runtime, data transfer, SaaS transactions, or internal service load. Model tools as metered resources. Estimate the unit cost, how often the agent calls them, what happens when calls fail, and whether retries multiply the charge. Also, watch for nonlinear pricing, rate limits, and minimum fees. A cheap call can become expensive when the agent explores repeatedly, duplicates work, or chains tools without control. Governance also has a cost. After a model drafts an answer, validation may check moderation, policy fit, hallucination risk, schema compliance, and answer quality. Some checks are inexpensive deterministic rules. Others are additional classifier or LLM calls, adding latency and token cost. The critical point is what happens after validation. A pass moves the response forward. A fail may trigger regeneration, more retrieval, tool use, escalation, or refusal. In cost models, guardrails are both a new cost center and an investment that reduces quality, safety, and compliance risk. A workflow cost ledger turns agent activity into accountable financial data. Each execution should emit cost events tied to the workflow ID, user request, agent step, and component used, whether that component is an LLM, retrieval system, tool call, validator, infrastructure, or human review. Capture the unit metric, such as tokens, seconds, calls, or review time, then multiply by the unit cost to calculate step cost. Add outcome, status, tenant, team, environment, task type, and policy version. With that consistency, you can support chargeback and showback, optimize workflows, detect anomalies, and strengthen governance. Cost per task turns a workflow trace into unit economics. For each request, add every measurable step: retrieval, planning, model calls, tool execution, validation, retries, response generation, and infrastructure allocation. Count the task cost whether the outcome succeeds or fails, because capacity was still consumed. A simple run might include 2 cents for planning, 4 cents for reasoning, 1 cent for retrieval and tools, plus 1.4 cents for validation and response, about 8.4 cents total. Segment that number by task type, tenant, route, or feature, then use it for pricing, budgets, and optimization priorities. Cost per outcome is where efficiency meets reality. A workflow may look inexpensive per run, but the real question is cost per successful resolution. Total workflow cost divided by successful outcomes. Failed attempts still spend money and often create rework, support tickets, or customer frustration. Escalations add another layer: the automation effort before handoff, plus the human labor needed to finish the case. Compare success, failure, and escalation together. That shows whether a low-cost workflow is truly economical or simply shifting costs downstream. Agent workflows rarely follow one fixed route. A request may move through the normal plan, tool, and validation sequence, or branch into extra retrieval, an alternate tool, a fallback model, repair, or human escalation. Each branch has 2 numbers that matter: how often it happens and what it costs when it happens. Retries are especially important because they can repeat expensive steps, so cost grows multiplicatively, not just additively. Strong models use production traces to estimate branch probabilities, then price both the happy path and the common exception paths. Average cost is useful, but it can be incomplete for agent workflows. One run may follow a short path, while another triggers retrieval, tool calls, retries, or validation loops. Probabilistic estimation treats those drivers as uncertain variables and models them with distributions: path probabilities, retry counts, token usage, or production histograms. The result is not a single number. It is a cost range, including expected cost, confidence intervals, P90 or P95 values, and worst-case exposure. That is how teams budget for volatility. Alerts and capacity plans should be tied to the tail, not just the average, because averages hide expensive rare cases. Cost models become valuable when they inform operating decisions. Start with guardrails, retry limits, tool call limits, routing rules, and escalation thresholds. Then compare cost against quality, so premium models or extra validation are used only when the value justifies it. Next, rank workflow steps by spend, variance, failure contribution, and quality impact. That ranking shows where optimization will matter most. Finally, connect the model to dashboards, alerts, experiments, and FinOps reviews. Governance becomes continuous, not a one-time spreadsheet exercise. Agent workflow cost modeling connects spend to reliable outcomes. Break each workflow into cost-bearing steps, then measure both cost per task and cost per successful outcome. Because agent paths vary, use probabilistic models for retries, escalations, and complexity. Next, we'll expand beyond tokens to include infrastructure, monitoring, data operations, human review, and organizational overhead.